Today we're looking at solving nonlinear systems of equations. So to solve any system of equations, there's a lot of methods. For this, we're going to focus on graphing. So to solve a system of equations by graphing, you graph all the equations and look at the points of intersection. So here's some that are already graphed. If I took this and I took one of the graphs and I outlined it in red just so we could see exactly what we're looking at, and then I took the other graph, the other line that was drawn, and did that in a different color, we're looking at where they intersected. So I could see that my two lines intersected at this point here, which would be -1. So it looks like these go by 1s, but these go by 2s. So -1, comma, -2, -4, -6, -8, -10. And then the other point is here at 2, -10. So this had two solutions, this system of nonlinear equations. For the second one, my two graphs don't ever intersect, right? One is a quadratic, a parabola opening up. The other is a quadratic, a parabola opening down, and they don't overlap each other. So this has no solution. It's possible that our system has no solution. It's also possible that we could use technology to do this. So there's two ways we can go about this. The easy way is Desmos. The more complicated way is the TI-84, the calculator. So for both of them, so I'm in Desmos right now, and I'm going to type my equation. So I have y equals 3x squared plus 5x minus 1. So there's my first equation, real skinny over there on the side. My second one is y equals -x squared plus 2x plus 1. Now I'm going to hide this for a second. Get a little closer, zoom in. And if I just kind of touch it, it's going to give me the points where they intersected. And these are gross points. So that would be 0.43, 1.67. It's going to go away, I think, when I touch this. Let's see. 0.43, 1.67. And then the other one was at -1.18, -2.73. Right, so these are not nice numbers. This would not come out nicely for us. Now I'm going to look at the graphing calculator. So here, after graphing both equations, so to graph equations, we would go to y equals, I'm going to type them in, so 3x squared plus 5x minus 1 is one equation. Now I'm going to graph the other one, -x. I can't remember if it works with the negative or I have to use the minus sign. We'll see. Plus 2x plus 1. Oh, okay. I thought that might be an issue. Negative there instead. Okay, graph. All right, we have our two graphs. So after we've graphed it, it says we're going to hit second trace. So second, and then up here, this line up here, trace. And option number 5 is intersect. So we're going to select 5. I can either scroll down to 5 or I could type the number 5. It's just going to highlight each curve. So it's on the blue one right now. So first curve, yes. Second curve, now it's on the red one, yes. They want us to make a guess. I don't think we care about that. Enter. So here's one intersection, 0.42, 1.68, and actually, I'm not entirely sure how we get to the other one. We have to, let's see. Second trace, intersect. I'm going to go to the other side of it. Okay, so we're going to select there. Select there. Okay, there's our other intersection, the -1.18. -2.73. So you can see it is obviously easier on Desmos to do than the TI-84. I believe you'll have both options available to you on the NJGPA. So obviously use whichever one you're more comfortable with, or if you have your own TI-84 calculator, it's great to know how to use that. So here's one for you to try. You can pause. Answers are posted on the blank notes on Google Classroom. All right, and let's do some NJGPA practice. So here we have the function. These two are defined below. The graphs intersect at point P. Determine the x-coordinate of P. Round your answer to the nearest tenth. So I'm going to be using Desmos for these because that's much easier to do. So I'm going to type in y equals 1 over 2x. And I have y equals x squared. So getting in real close. They only intersect once. Right here, they want just the x-coordinate of P. So that would be 0.79, 0.7937. Oh, they round to the nearest tenth. 0.8 is rounded to the nearest tenth. And one more, at what points do f of x and g of x intersect? Select all that apply. So we don't have to type both the y and the f of x or g of x, so we can just do y. So y equals absolute value of x minus 3, and y equals x squared minus 5x plus 6. So I see definitely 1 here at 1, 2. So we know we can select 1, 2. And I also have 1 here at 3, 0. Right? There's nothing at what would be negative 3, 6. That would just be one of the graphs. There's nothing at negative 1, 4. Again, that would be just one of the graphs. There's nothing at the 1, 4. That's just one of the graphs. So these would be our two choices. And that's it for nonlinear systems.